Hello everyone, welcome back. So in this next video this week, we are going to be talking about our core game mechanic for zombie apocalypse, which is collision detection. And odds are this is a concept you're going to be needing for most of the games you're probably proposing to build. Okay? What I mean by collision detection is simply the idea that we need to know when our game objects overlap with each other in order to be able to do something in the code to respond to that occurrence. In this case, eventually this is what's going to trigger our game over state. Okay? So how do we handle collision detection? Well, again, like with everything in programming, there's a myriad of ways we could approach this. Let's talk through the problem using a few slides, and then we'll talk about, we'll look into implementing it in our code. Okay. All right. So first thing to establish is that the idea of trying to determine if two irregular shapes are overlapping is kind of hard. Okay, there's a lot of detail that go even in this simple kind of pixelated zombie and player. And if we wanted to make this pixel perfect accurate, we would have to work quite a bit harder. This is beyond the scope of this tutorial. So instead, we're going to take the easy way out, which turns out to also be good enough in a lot of cases, and and is perfectly usable, right? For things like if you had a spaceship shooting bullets and so forth. Like sometimes in a game things move kind of quickly, so approximating collisions is often the correct way. Not only is it simpler, but it's also faster. So if you have lots of objects that need to do collisions with one another, this is a really good starting point. Okay. Oftentimes, actual games will have something like a circle collision as the first step, and then once you determine there is kind of a rough collision, you can go into the more detailed version. We're not going to go there for this tutorial. Okay, so collision between irregular shapes is hard, but collisions between circles is shockingly easy. So imagine each of our game objects are going to have this kind of invisible bubble around them. Now our task is going to be to determine if these bubbles collide into each other or not. Okay. So how do we do circle collision? Well, here's an illustration of that, right? So first we measure the distance between each circle. Okay, so in code terms, that's going to be taking the position of each object and measuring the distance in pixels between those. And we know we have a dist function we can use that will do exactly that. Once we've measured the distance, okay, we're going to compare that with the sum of the radius of each circle. Okay, so if we know the radius of circle 1 and we know the radius of circle 2, let's call those radius 1 and radius 2, we're going to compare those with the distance. Okay, and there's basically two scenarios. Two things can happen. Scenario 1, the distance, right, is going to, we don't collide, right, the two are apart. Or scenario 2, the circles in fact do overlap, they are colliding. Okay, and we can already see what's going to happen, right? What the relationship between the distance and the two radiuses, radii, I don't know, is going to be. Okay, so in the first scenario, we have distance is greater than the sum of the radius. That means our circles are apart. Okay, in the second scenario, we have the distance is actually less than the two radius put together. This means we have a collision. Okay, so we can ask a question in code, right? Because this is simply comparing numbers with a greater or less than sign. So this is something we can ask in code very, very easily. All right. So let's take a look at how we would implement this in our program in actuality. So the first thing we need to add is the concept of a radius. Currently, our program doesn't have that. If we look at the player class, right, what's the radius? Well, we could take a look at the images, maybe the sizes and so forth, but we're going to be more straightforward here. We're going to simply say, if we need to add an imaginary invisible bubble to our player, all that really means is we just need to add the concept of a radius to our object, and basically as a variable. So let's start with, I'm just going to put the number 25 here, and we can visualize this radius if we wanted to very easily. We can just say, okay, when we draw our player, let's also, turn off the fill, set a white stroke, and draw a circle. Okay. It looks like that. Okay, so obviously 25 is not going to work. Let's try something bigger. 50. Okay, that's good enough. So this is going to become a trade-off between how loose our collision is, right? The bigger we make the circle, we might have times when the zombie might eat the player when you're not really touching. So we're going to kind of do a bit of a compromise here. I'm going to go with 50. So this is going to be my circle I'm using for collision detection. Okay, so in other words, maybe the top of the cap or my shoes, I can get away with it, but if the zombie kind of gets into that circle, that's going to be the player. That's going to mean a collision. Okay, so we could tweak that number if we don't like it. We could do the same to the zombie. Okay, so we're going to add a radius to our zombie. So we're going to go into our zombie class. In the constructor, we're going to add the same radius. And just so we can see it, we're going to draw it. Okay, this is not something we want to have in our final game, but for now, because we're developing it, we're going to add a bit of code in the zombie drawing code as well, so we can see the circles, and that's going to help us kind of make sure that things are working the way we expect them to. Okay, so now we're drawing the radius, but again, radius is just a number, right? So it's just a concept. What we now need to do is figure out, are these two circles overlapping? And then we'll know that the zombie has caught up with the player. So we can let's do that in draw as a first pass. Okay. So how do we know when two circles overlap? Well, going back to the slides, step 1, we need to measure the distance. Let's call that D. That's going to be the distance between circle 1 and circle B. In this case, we have the distance between player.x, player.y, and zombie.x, zombie.y. Okay, so we measure the distance between these 2 points. That's going to tell us how far apart the 2 circles are. And then if we want to know if they overlap, we compare that distance with the sum of each object's radius. And the radius don't have to be the same. They could be different. That's still going to work. And if the distance is less than player.radius plus zombie.radius, zombie.radius, right? So if the distance is less than the 2 radius added together, that tells us we have this scenario happening, right? The 2 distance added together are greater than the 2 radius added together are greater than the distance between the centers. Therefore, they must overlap. Okay, it's only ever going to be one of these scenarios here. So if that happens, we know we have a collision. Okay, so we could do something in our program here to kind of know that this is happening. Okay, so for example, I'm going to set a let's draw some text. Okay, we're going to draw a little bit of text just to test it out. We're going to draw some text. If this happens, right, let's draw some text above the player. So we'll take player.x and player.y minus 25. Okay, where does that appear? Over here. Actually, let's move it further down and let's set a white fill so we can see what we're doing. Okay. All right. So it doesn't have to be amazing here. The point is we just want to see if the collision code is working or not. Okay. So already here I'm getting a sense that this is not quite working. So why is that, right? So this is happening sooner than I think it should, right? This is where and I did that on purpose just to show you the benefit of adding this kind of visualization layer to your code when you're developing. Okay, so now I've added the circles and I can immediately see something is not right, right? So why is the collision triggering so soon, right? That's because in my player class, right, I'm confusing here the radius concept with the diameter of a circle. Okay? So in reality, this circle, in order to be accurate, this should be radius times 2, right? And same thing with the zombie, this should be radius times 2. And this would be really, really difficult to tell if I wasn't drawing, right? Visually representing the values that my variables have somehow in the code. Okay? So this idea that, we're kind of adding this debug code, this layer of code that's only helpful to us, the programmer. This is not going to be part of our final game, right? Oh, now we see it's working correctly. This can be very, very helpful. So in addition to printing things to the console, don't forget that you have access to your canvas. You can draw whatever you want on there as you're developing to help you figure out, are things doing what you think they are, right? So here, by making this abstract idea of the radius, by making it visible, right, I can now quickly see, right, okay, now this is behaving the way that it should, right? So this was an easy mistake to make, to define the radius and then forget that circle parameter actually takes a diameter, right? So this is not a far-fetched potential error. And I was able to catch it very quickly because I've added this bit of code here that sort of debugs and kind of helps me visually understand what's going on in my program. Okay. So now, for example, we might tweak the radius. Let's make it smaller, 25, right? Back to a smaller number for the zombie. Let's make it smaller for the player. Okay. So that seems a little bit more fair. So now there's a collision only when we're actually like pretty close. And you might still touch the feet or the head, and you just, let's chalk this up to, this was just a lucky break for our player, right? And you have to get close to the zombie to trigger the collision. Okay? So that's going to be our core game mechanic for this game. Now we know we have the ability to tell, right, if the player overlaps with an enemy, and then we can build everything else on top of that, including having different game states, transitioning between game states, and so forth. But excuse me. But before we move on to the next videos about this, let's talk about a few improvements we could make to this version of the code. Okay? So the first improvement we're going to make is we're going to turn this collision concept here into a function as well. So just like we made load frames into a function, a reusable function, let's go through the same exercise with the collision concept. And in this particular program, there's no real benefit to it because we're only ever going to be checking collision between the player and the zombie. So we could get away with leaving it as is, and it wouldn't be really a big deal. But I'm going to show you how you would write it as a function, because maybe in your game that you're creating, maybe you have all kinds of different elements that might all need collision as a concept. So if we can make this more general, right? This is now some building block we'll be able to reuse anytime we need to compare two game objects that have a radius property, right? We'll be able to tell if they overlap or not just the player and the zombie. Okay? So let's see how we would do this. Let's define the function just right here so we can see both things. Okay. So let's call this collision. Okay. And when we write the collision function, it's not necessarily going to be between the player and the zombie. It's just going to be between two things. Okay, let's call those things A and B. So the parameters here could be anything, right? A and B is just going to be two different objects in our program, and A and B must have a X, Y, and radius attribute. Okay, so that's the only kind of constraint we have, is that as long as our A object we pass and our B object we pass inside of them have an X and a Y and a radius, this code is going to work. Okay. So how do we do this, right, in more general terms? So it's the same idea, right? We're going to measure the distance between a.x and a.y and b.x, b.y. Okay. What's a and b? I don't know, right? It depends what objects are going to be provided when we use our collision function. But it doesn't matter. I'm just going to assume they have an X and a Y, and an X and a Y, both of them, so I can measure the distance between them. Okay? If you want it to be fancy, we would add code that would check if they in fact have an X and a Y and then throw an error if they didn't. We're not going to get that fancy in our program. We're just going to trust ourselves to remember that these objects, and we put a little comment here to make sure we remember. So we're just going to trust ourselves to give good objects to this function that have the required attributes. Okay? All right, so the same as we're doing here, we're going to measure the distance, and then we'll use an if statement to decide, is there a collision? So if the distance is less than a.radius plus b.radius, right, then we know there's a collision. So we're going to return true. I'm going to say yep. Otherwise, return false. I'm going to say, no, there's no collision. Okay? So now what we've done is we've taken the concept of the collision detection, which initially we wrote specifically for that player and that zombie variable, and we've abstracted it out in a more general function. Okay? This function will work with any two objects as long as these objects have an x, a y, and a radius. Okay? And this now becomes reusable. And we could use this in our program anytime we want to check if two objects collide. Okay? So in this game, we're not going to have that opportunity, but maybe if we had more time, we might add a mechanic where the player can shoot some throwing axes or whatever, and then we might have now a throwing axe object, and we need to know if that collides with the zombie, so we would be able to reuse this collision code we've already figured out, right? So we don't have to constantly reinvent the wheel. We can scaffold on top of what we've already solved. So now that we have this collision function, we could use it in here instead of just having math, right? In the if, we can get rid of all this and we can say if there is a collision between player and zombie, right? So the outcome of this will either be true or false. So we could, if we wanted to, we could do that if that's equal to true, but because it's true or false, we kind of don't need it. We can just leave it out. The whole thing is either going to be true or false, so that can be right into an if. Now we know we have a collision, we can do the fill white and the text. Okay? So same difference, right? The code works exactly the same as before. The only difference is we've structured it a little better, right? So we've taken the time to write our collision detection code, make it more general, put it into our function so that down the road, if we ever need to do this again, right, we don't have to resolve it. We can just use the command that we made. So this is a great example of another little function, just like load frames, right? That basically, with a little bit of work up front, makes our lives easier down the road. Okay? All right. The last thing we're going to talk about is these white bubbles. Okay. And in this case, they were very useful because they allowed me to figure out what exactly was going on with my program. Also, I could visually tweak the size of the bubble, right? So if I wanted to adjust the size of my collision detection area, I could visually tweak it now to make it just right. Maybe I want it a bit smaller, a bit bigger, and so forth. But I don't want these to be in the final game because they're distracting. So we could comment out in the final game, right? We could decide, okay, I'm going to comment this out and then run the code. Okay, so now I've gotten rid of it. I would have to do the same for the zombie, right? Okay. But then maybe down the road, I'm playing this game a little bit. I'm realizing actually it'd be nice to tweak those circles again. Now we have to backtrack, uncomment this, right? Uncomment that, and so forth. Maybe in your game, you have other places in the code where you are adding layers of things you're drawing that are only there to help you understand what the heck is going on. Maybe you're drawing some text that's showing the position of objects or whatever it is, okay? And you want to be able to kind of turn these on and off more easily than commenting out blocks of code all the time, okay? So this is a common scenario. And one thing that I like to do in that situation is to have one variable at the top of my program. Let's call that variable debug. When you're debugging in programming, you're like troubleshooting, you're finding out problems. Let's define this variable as a true or false value, and you can think of it as basically like a light switch, right? It's either on or off. And then anytime in our program we have little sections of code that we want to be able to take in and out of the program without having to go and comment them out like so, we are going to refer to our debug variable. Here we're going to say if debug, right? We're going to use if statements to decide if this code should run or not. And the answer will be based on the value of the debug variable. Okay? So if debug is on, we're going to draw the circles. If debug is off or it's false, we're going to skip the circles. Right? So this is nice because now we don't actually have to use comments to take the code in and out as we're testing things. by putting them into these if statements, I now have one place I can go at the beginning. I can say if debug is true, I'm going to have all of my kind of extra visual aids I've built into my code to help me understand what the hell is going on. And if debug is false, I can now toggle it. I can go to the beginning, turn them off. Okay. This is a very useful trick, not just for games, for anything you're making with code, right? You're always going to have some kind of mode that maybe you're writing code for an art installation and you need to have stuff that appears on screen only when you're doing this setup, right? Only when you're installing, and then you want to be able to turn it off. Well, there's now one line, one place that this can happen. Okay, so you can go back and forth between that, and then throughout your program, you can kind of insert whenever you feel like it these little if statements that will have additional code that will run only if debug is true. Okay? So really useful strategy, so you don't have to constantly take things in and out. And maybe you have so something you might want to consider for your own projects as well. Again, just the goal here is to make our lives easier, and the more information we have when we're programming, the easier it is to figure out what might be going wrong and what we need to do next. Okay, so we're going to leave it at that. Now that we have collisions, in the next video, we're going to finally talk about introducing game states, which means this program now, which is just like the two characters kind of aimlessly chasing each other, we now need to be able to have some kind of a progression, right? We're going to start with an intro screen, then we'll jump into the game, and then once the zombie catches us, we're going to move to a game over state. So we're going to talk about how we would structure that in our program. I'll see you in the next video.